Assalamu alaikum. Today we are going to start a new topic, that is hydrostatic pressure and its application. Hydrostatic pressure. Hydrostatic pressure and its application. I have sent you the questions in the group. Take the MCQs. 2014, 23rd question. 2014, 23rd question. Use the information given below to answer questions number 23 and 24. PQR are three identical glass tubes with one end closed. Equal masses of a certain gas are trapped by introducing mercury column of length 5 cm, 10 cm, and 12 cm in the tube as shown in the figure. The tube P and Q are kept vertically and the tube R is kept horizontally. Which tube or tube contains the gas column with a pressure equal to atmospheric pressure? Now, you have learned this now. We are going to take a YouTube. We are going to take a YouTube. We are going to take a YouTube. Before that, here I have a container that is filled with water. This is filled with water. Now, if they asked what is the pressure at the bottom, what is the pressure? Now let us take this point as A. What is the pressure at A? How you will find? You know, due to atmosphere, there is a pressure at this point. Due to atmosphere, there is a pressure that is known as that is atmospheric pressure. Due to atmosphere, there is a pressure on the water surface that is atmospheric pressure. Now, let me take this. I have taken PATM as atmospheric pressure. Okay, PATM. Let me take the pressure due to atmosphere as PATM on the surface of water. And you know, due to pressure due to water, there will be a pressure at this surface A, also at the bottom of at the point A, also due to this water inside the container. That pressure is known as hydrostatic pressure. Pressure due to water. Here there will be a pressure due to atmosphere, that is atmospheric pressure, and also there will be a pressure at this point due to water in the container, that is the hydrostatic pressure. Therefore, let me take this as pH. Therefore, pressure at A is equal to PATM plus pressure due to hydrostatic pressure due to water. This atmospheric pressure, the value of atmospheric pressure, they will give in the equation. The value of atmospheric pressure, they will give in the questions. In the question, they will give this is the value of atmospheric pressure. How are you going to find this? The pressure due to water or hydrostatic pressure. You know the equation. Hydrostatic pressure is equal to HdG. HdG. What is this H? H is height of water. And what is this D? Density of water. Density of water. And what is this G? That is gravitational acceleration. Gravitational acceleration. So let me take the water is filled up to a height h, up to a height h, and the density of water is d. Density of water is d. Therefore, pressure due to the this thing, what is that? Hydrostatic pressure is equal to HdG. Therefore, the total pressure at A, total pressure at A, total pressure at A is equal to PATM plus pH. No, this pH is equal to HdG. This is what it is. Hydrostatic pressure. You know what is this hydrostatic pressure? Its application we will study later. Okay. I will put the voice note I will put the short note and the voice note in the group. Now, I just told you this to remember your theory. Now we'll move to the question. Yeah, I will tell you about this YouTuber. So how to do this YouTube practicals? YouTube. Here I have a YouTube. Okay. Now I have filled. I have filled with water. So here there is water inside this. There is water inside this. Now what am I going to do? I'm going to tie a balloon over here. I'm going to tie a balloon, or else with the use of the syringe, I'm going to increase the pressure here. Now what am I going to do? With the use of something here. With the use of pump. I have a pump here. I'm going to increase the pressure. I'm going to pump this and I'm going to increase the pressure. So now what will happen? Now what will happen? Here is the initial water level, right? This is the initial water level. Now what will happen? From this water level, due to increasing pressure, the water level goes up here. Now what will happen here? The water level will drop down to this height. So this is the new water level in the column, in these two columns. Is the new water level. So I'm going to equate the pressure. How are you going to equate the pressure? You know, under pressure there are 5 points. In that 5 points, one of the point is pressure at same height. Pressure at same height is equal, right? Pressure at same height is equal. So I will take this point. I will take this point. I will take this point. Here, let me take pressure here is P1. Pressure at this surface is P1. And there will be a pressure. If it is P1, here also it is P1 no, because pressure at same level is equal. No. Pressure at same height or same level is equal. Same level is equal. If there is P1 pressure here, then here also there should be P1 pressure. You know, what is this P1 pressure? The pressure due to atmosphere. Pressure due to atmosphere and pressure due to the hydrostatic pressure. PATM plus pH. So here, how we know that this pressure and this pressure is equal? Now, what is this P1? This P1 is equal to PATM plus H rho G. HDG, this is P and this is the height of H. Then pressure at this point is equal to pressure ATM plus hydrostatic pressure, that is H rho G. Therefore, with the use of this, you know PATM, you know H, you know D, you know G. From this, you can find the pressure at this point. Okay. Now, there are these type of questions in the past papers. We'll do all these things. I'm just giving you the theory. Now, in this practical, you see the P1, P. Here we have P. And then there is another one, Q. And there is another one, R. R. It is 5 centimeter. It is 10 centimeter. And then here it's 12 centimeter. 12 centimeter. So, this is mercury. You know this mercury, right? Now, the thermometer, the tip of the thermometer, there will be a red color liquid, no? That red color liquid is the thermometer. Sorry, not the thermometer. Red color liquid is the mercury. Okay. Now, this is a mercury column. Now, how are you going to take this mercury and all? You don't need to know all about these things now because those are in detail in the A level. Just you take that they have taken a mercury and this mercury level is like this. Inside the tube, inside the P, there is a mercury column of 5 centimeter. Inside Q, there is a mercury column of 10 centimeter. Inside R, there is a mercury column of 12 centimeter. Now this P and Q are vertically present. This R is horizontal. It's existing horizontally. Okay. So what is the question they are asking? The tube gas column with a pressure equal to atmospheric pressure. In this tube, now here we can see there is mercury column now. This part is exposed to atmosphere, right? When this part is exposed to atmosphere, there is a pressure due to atmosphere, that is PAT. At this surface, there will be pressure due to atmosphere. Here also, there will be atmospheric pressure. Here also, there will be atmospheric pressure. Okay. And as we said in the water, and I said you in the YouTube, when there is a water column, there will be pressure due to atmosphere, and there will be pressure due to that particular height of water. That is hydrostatic pressure will be there. Now here also, this liquid, this mercury is a liquid. No, because of this liquid, there will be a pressure. Now here there will be air. Here there will be air. there will be air. Here also there will be air. So what is the pressure in the air? What is the pressure inside the empty space? Empty space in this tube P. That is the pressure due to atmosphere. Now let me take the pressure inside this as PP, and here as PQ, and here as PR. Now the pressure inside in the space, the pressure in this space is equal to pressure due to atmosphere and pressure due to this height of mercury. Pressure due to this height of mercury. Therefore, PP is equal to PATM plus, this is, they have given, H rho G no. Likewise, H into, now let me take density of mercury as dm. Mercury no. Mercury starts from M no. Therefore, let me take it as dm as simple. dmg. Okay. Now, let me take this Q. What is the pressure at Q? That is equal to PATM plus, let me take this as height. Given height now. So let me put as 5. Now, let me take this H1 now. This is H1 and this is H2. Therefore, PATM plus H1 DMG. Here, PATM plus H2, right? This is the height now. H2, the same liquid is present, same mercury is present. Here also mercury, here also mercury. Here the density is dm, here also density is dm. So dmg. So you know the pressure at P, here the empty space in the air, and the pressure here the air. And what is the pressure at R? You know, when it is vertically present, the pressure at here is due to atmospheric pressure plus the pressure due to this side. Here also due to atmospheric pressure and also pressure due to this mercury. But here, this cube is horizontally present. It is present horizontally. Now, how can this mercury column will remain at this level? How can something be in equilibrium? How can something be in equilibrium? The downward force should be equal to upward force. We have studied this in equilibrium, right? For an object to be in equilibrium under two forces, the two forces should be in opposite in direction, should be equal in magnitude, should be in same line of action. Okay, for an object to be in equilibrium, resultant force should be 0. Likewise, here for this mercury column to stay at that level, pressure now you know, right? Pressure is equal to force over area. No? Pressure is equal to force over area. Force is equal to pressure into area. So due to this pressure, now let me take this as area A. Area A. So there will be a pressure at this point. There will be a force at this point that is equal to force at this point. Force is equal to pressure into area. No? Here PATM into area. Now this is, I am explaining you in very detail. They won't ask such questions in nowadays. They won't ask this type of questions. This is an earlier question and a good question. Please check this. Therefore, force here is pressure into area, that is PATM into A. And there will be a downward force for this mercury from this pressure. Okay. Now, due to this air, there will be a pressure in the upward direction to this mercury. Now, let me take this mercury separately and let me show it to you. Here I have the mercury. This is the mercury. Due to atmosphere, there will be a force. And due to the air inside this, there will be a force in the upward direction. Okay. This force and this force will be equal opposite in direction. Will be equal opposite in direction and same line of action. That is why this mercury column is in equilibrium and it stays at that position. That is the same thing here. There will be due to atmospheric pressure, there will be a force. That force is equal to the force exerted by air inside the tube Q that force and this force will be equal, opposite in direction, same line of action. Therefore, this will be in equilibrium. But here you see, due to atmosphere, there will be a force in the backward direction or in the left side direction, and also due to air, there will be a force due to air, there will be a force in the forward direction. So, there is no any vertical force when an object is under equilibrium under two vertical forces. Under two forces mean the resultant should be zero. No? First resultant should be zero. Forward force equal to backward force. Same line of action, opposite in direction, equal in magnitude. Therefore, this object is in equilibrium. Likewise, for this mercury column to be in equilibrium, to stay at that position, pressure due to this should be equal to pressure due to this. Now, area is same. No? Here I have taken this as A. Here also area A. Here also area A. Okay. Now let me take pressure due to ARS. Now let me take pressure inside this as PR. Therefore, there will be pressure here now. Same area, same. There will be a pressure PR and there will be pressure PAT. You know, force is equal to P into A. No? Force is equal to P into A. No? Now, what will be the force due to atmospheric pressure? That is PATM into A. Likewise, due to this P or due to the air inside the air in the space, there will be pressure to this mercury in the forward direction. And let me take it as, now here this is F1 and this is F2. Okay, this F1 force due to atmospheric pressure and F2 force due to the air inside the tube R. This F1, this F2. Therefore, F2 is equal to PR into A. Okay, then for this to be in equilibrium, we know F1 should be equal to F2. Then only this will be in equilibrium. Therefore, F1 is equal to PATM into A, and that is equal to F2 is equal to, what is F2? PR into A. A and A will cancel off. Therefore, PATM is equal to PR. Therefore, you can see here the pressure inside the air is equal to atmospheric pressure. I have proved this. I have proved this with the explanation. I have not just said you this will be equal to this. I have proved it and I have showed it to you. How when it is in horizontally, when the tube is present horizontally, pressure due to atmosphere is equal to pressure inside the air column, pressure inside the air column. When the tube is horizontal, when the tube is present horizontally, atmospheric pressure is equal to pressure due to air in the tube. That's it. Therefore, answer should be R. That means answer should be third. Answer should be third. I have given you detailed explanation. The pressure is equal to force of area. Force is equal to P into area. For this to be in equilibrium, F should be equal. F downward and F upward should be equal. With those, I have explained to you. This is on the equilibrium part. You studied this side earlier. Application of that to this hydrostatic pressure. You see. That's it. I am going to clean this. 2014 24th is not in your syllabus. It's in A level. It's in A level. 2014 24th. You don't need to do it. It's A level part. I also don't need to explain to it. It causes waste of time. They won't ask those type of questions. In earlier syllabus they asked, but in the new syllabus they won't ask this. I'm going to clean this. Now take 2015. 2015 31st question. 2015 31st question. Consider the following containers 1, 2, 3, 4. The four containers are filled with pure water up to the height of 12, 15, and 14 respectively. PQRS are points located at the bottom of the container. Of the points, which point experience the maximum pressure due to water? You know the theory, and also there is something that is in your book. An experiment is in your book, like this. Water is full like this. Okay. Now is built to the same height. This H1, H, H, H. Now let me take the pressure due to this tube here as PA. PA. Pressure due to this is PB. And pressure here as PC. What is the largest pressure? Minimum pressure. Will the pressures A, B, and C will be equal? Yes, A, B, and C will be equal because the pressure doesn't depend on the shape. Pressure at a point will not depend on the shape, but the pressure depends on height. Pressure depends on height, not depend on the shape. You see, here also height is h. Here also height is h. Here also height is h. So, as I said you earlier, what is PA? Pressure at A is equal to pressure ATM plus HDG. PB is also same. PC is also same. Because here you see at all the points, what is the pressure acting at the same level? You know, PATM, PATM, PATM will. Now let me take density as D. Density as D. Here also same liquid, no? So density D. Here also same liquid, no? So density D. Therefore, pressure at A is equal to PATM plus hydrostatic pressure. What is hydrostatic pressure? What is the equation for hydrostatic pressure? That is H rho g. That is equal to P. What is this PB? PATM plus H rho g. What is PC? PATM plus height. No need to think of the container. Pressure depends only on the height. Doesn't depend on the shape. That's it. Therefore, answer is yeah. Okay. For this, it's okay. But you see, in the question they have given 1 and 2, the height is 12 centimeter. Height is 12 centimeter. In third, height is 15 centimeter. In fourth one, height is 14 centimeter. Pressure depends on height, no? When height increases, when height increases, when height increases, pressure increases. I will not say height is directly proportional to pressure. If height increased by 2 times, pressure increased by 2 times, no, it's not like that. But if height increases, pressure increases. That's why height increases, pressure increases. Therefore, from 1 to 3, 4, the largest height is present for the third option, which is 15 centimeter. Because it has the highest height, Therefore, the pressure at R is the highest pressure. And then if they asked about the pressure P and pressure Q, they will be equal because the height is same. No? The height of the water in the container, in the diagram, they have in the first option, height is filled up to 12 centimeter. Second option is also filled up to 12 centimeter. Therefore, pressure at P and is equal to pressure at Q. Yeah, if we write the variation of pressure, how this pressure varies, I can write like this. Yeah, the highest pressure is for, if they ask the how, now they can ask like this, the decreasing order or the increasing order. If they ask the question as decreasing order of pressure, decreasing order of pressure. Decreasing means what? High to low, no? High to low. So which one has the highest pressure? That is PR, PQRS, right? R, after that for S, after that for P is equal to Q. This will be the answer. If they ask the increasing order or the decreasing order, the descending order, this descending order or ascending order, that is from small to big. Small to big means low pressure to high pressure. What's the variation? It's opposite of this. E is equal to Q, low to high, right? S R. This should be the variation. So they can ask this type of questions. The variation of pressure, how the pressure will vary. They can give choices like this. And they can ask the decreasing order, increasing order. Therefore, this is the new type of question they will ask. Yeah, for 2015 done. Next 2016, 21st question. I'm going to clean this. So what's the answer for this? Answer is our third one. Now 2016, 2015, 21st question. Sorry, 2016, 2016, 21st question. What is the pressure exerted by water at a point located 2 meters vertically below the water level in a lake? Take the density of water as 1000 kg per meter cube. Acceleration due to gravity as 10 meter per second minus 2. That's an easy question. Here, water is filled up to a height of 2 meters, and they have asked the pressure at this point. You need to find the pressure at this point, 2 meters, and they have given density of water as 1000 kilogram meter cube, 1000 kilogram meter cube, and they have said the gravitational acceleration is 10 meter per second minus 2. And you see, what are they asking? They didn't ask the total pressure here. They didn't ask just the pressure. What they asked the pressure due to water. Pressure due to water. What is pressure due to water? That is hydrostatic pressure. Hydrostatic pressure. What is hydrostatic pressure? That is HDG. Therefore, remember, they have asked pressure due to water, not just the pressure. If they ask just pressure, then the pressure P is equal to PATM plus HDG. But they asked pressure due to water, that is HDG. So what is it? Height is 2. They should be given in standard units. If they are given as 2 centimeter, convert that into meter and substitute to this height. They're given in centimeters. How do you convert to meter? Divide by 100. After that only you should substitute here. Now this density, there should be given in kilogram per meter cube. You know, density is equal to mass over volume now. What is the unit of mass? That is kilogram in SI unit. What is the unit of volume? Meter cube, that is in SI unit. Therefore, kilogram, if I take this meter cube up, kilogram per meter cube. Okay, therefore density is 1000 into, what is this G? They are given as 10 meter per second minus 10 meter per second minus 2. Therefore, 2 into 10,000, 2 into 10,000. 2 into 10,000 is 20,000. 20,000. What is the unit of pressure? Unit of pressure is Pascal. Unit of pressure is Pascal. Okay. Therefore, what should be the answer? 2016, 21st. Answer is 4th. Answer 4th. Okay. Then now 2017, 2017, 27th question. 2017, 27th question. A situation where a swan of mass 1.3 kilogram is at still water in a pond is given in the figure. What is the upthrust acting on the swan by water? Take the value of gravitational acceleration 10 meters per second. Okay, upthrust comes into action. Upthrust. You know, I have a container. I have filled this with water. So when an object is dipped into water and when it is floating, when an object is floating, now why is this floating? Why isn't it going down? Why is it not going up? Why half of the cube is filled with water? Why half the volume of this submarine? Let me take this as cube value. This cube, half of the cube is covered by water. Remaining half is exposed to the air. They are not filled into the water. Now you know when an object is in the water, there will be a new force exerted on this object. A new force will act on this object. What is that new force? That new force is upthrust. Upthrust. And also, you know, always there is a weight for an object. Okay. Due to this weight will always act in the downward direction. Okay. So therefore, there will be a weight acting on this object. Now, why isn't this object moving down or up? Why is it standing at that position? If it is standing at that same position, you know that object is in equilibrium. That object is in equilibrium. That object is in equilibrium. That is at equilibrium now. If that object is in equilibrium, downward force equal to upward force. What is the downward force? That is W. Let me take this upthrust as U. I will take this symbol as U. Upthrust, weight is equal to upthrust. Okay. So what are they asking? Swan of mass 1.3 kilogram. Given in the thing, what is the upthrust acting on the swan by water? Take the value of gravitational acceleration, just 10 meters per second. Now, what are they asking? They are asking this upthrust. You know, upthrust is equal to weight. No, they have, you know, weight is equal to mass into gravitational acceleration. No? They have given the mass. What is it? 1.3 kilogram. 1.3 kilogram. 1.3 kilogram into gravitational acceleration. What is the gravitational acceleration? They have given us 10 meter per second, right? Yeah. 10 meter per second minus 2. Therefore, 1.3 is into 10 is 13 kilogram meter per second minus 2. What is this kilogram meter per second minus 2? That is the unit of force, right? Therefore, 13 Newton. So answer should be 4th. 2017, 27th. Answer 4th. So 2017 is done. So now we are going to move to 2000. If you entered, you ask with me. 2017, 27th. Next, we are going to 2018. 2018. In 2018, there are 3 questions. 2018, 12, 32, 37. 12, 32, 37. Take this. 2018. Okay, 12th question. When a block of wood A is placed in a liquid, it floats with a part immersed. Which of the following is the true statement in relation to this? The upthrust exerted by the liquid on A is equal to total weight of A. The second statement, the weight of the liquid displaced by A is equal to the weight of the part of A displaced in the liquid. The weight of the liquid displaced by A is equal to weight of the part of A immersed in the liquid. Third statement, volume of the liquid displaced by A is equal to the total volume of A. The density of A, the first statement, density of A is equal to density of the liquid. Okay. As I said you in the earlier question, 2017, I have discussed a question with the calculations I have shown it to you, I have said to you. Now, when an object is partially immersed in a liquid, when an object is partially immersed in liquid, when part of swan is in 2017 question we discussed, swan is floating on the liquid. A part of the swan is under the water. Likewise, when here also a block of wood is partially immersed in water. When a block of wood is partially immersed in water, when a block here, block of A is this part is immersed in water, you know, there will be a weight and there will be upthrust. There will be weight and there will be upthrust. So this when object is partially immersed, you know, weight is equal to upthrust. No, weight is equal to upthrust. Now, what is this upthrust? What is the equation for upthrust? You know, what is the definition of upthrust? Upthrust is equal to weight of water displaced by object. Now, when this object is partially immersed in water, this part of this whole cube, that this part of wood, here the shaded part of wood is displaced, is dipped into the water. Now, when that part is displaced into the water, the same volume of water will be displaced inside the container. Now, initially, let me take this is the level of water. Okay. After this cube is dipped into this, after this cube is dipped into this, let me take that it is going to displace. Now this volume is V. This volume is V. Now what will happen? Now what's the volume? Now what's the level of water inside the container? What will happen? This part of volume is occupied by this wood, no? This part is occupying this part of volume, no? Okay, now what will happen? The water level will rise. The water level rise by this amount. This is the height of water raised. Now, what is the new volume of water? This is the new volume of water. This is the new volume of water and block of wood. Here, this is the volume of the wood that is inside the water. Therefore, what has happened? When the wood is, when a part of wood is displaced into the water, that same volume of water will be raised into the container. Now let me take the volume V of the total wood is dipped into the water. V portion is dipped into the water. Okay. Now let me take this as V. V is the volume of the wood that is immersed into the water. The part of wood that is immersed into the water. Now that same volume V will be raised by the same volume V will be raised. Now let me take this V now. You know volume is equal to area into H now. Volume is equal to area into H now. Now let me take this area A. This has raised by a height of H. Therefore, the volume that the part of wood of volume V is displaced into the uh, V portion of the wood is into the water now. That same V portion will be displaced by the water. Same V portion will be displaced by the water. That is what it is. The same V will be occupied. Okay. That V is equal to area into H. No, this area is A, this is H. Therefore, volume displaced by this is equal to A into H. Now you don't know about this A into H. Just remember. Now the V portion is into the water now. That same V portion will be displaced by this wood. That is what it is. Upthrust is equal to weight of water displaced by object now. Now, what is the volume weight of water displaced by object? Now, what is the volume that is displaced by this object? What is the volume displaced by this object? That is equal to the volume of this object into the container. Now, they have taken this as wood now. Therefore, upthrust is equal to weight of water displaced by the wood. Okay. Now, what is the volume of water displaced by this wood? That is equal to V now. That is, I am taking this as V. Now, this V is equal to the volume of the wood, volume of wood into the water. Volume of wood into the water is equal to volume of water displaced by this wood. You know, volume is equal to, now density is equal to mass over volume. Density is equal to mass over volume. No. Mass is equal to density into volume. Now, let me take density of water as D. Okay. We need to find the weight of water displaced by the wood. I know the mass of water displaced by the wood. That is, mass is equal to D into V. Then what is the weight of water displaced by the wood? That is equal to mass into gravitational acceleration. Mass is dVg. That is Vdg. Is Vdg. Okay. Therefore, what is the equation for this upthrust? thrust is equal to VdG. Okay, what is this? D is the density of liquid. G is the gravitational acceleration. What is this? V is volume of object submerged in water. Volume of object submerged in water. Okay. So I have tell you the theory. I have given you the explanation for the theory. Okay. Now in 12th one, first one they have the first statement. Upthrust exerted by the liquid on A is equal to total weight of A. Yeah, it's correct. Is what I have said. Upthrust is equal to total weight of A. Therefore, first statement is correct. Then what is the second statement? The weight of liquid displaced by A. That means, I said you earlier. Now, what is the volume of water displaced by the wood? Volume of water displaced by A. That is V. No, I have shown it to you earlier. No, that is V. The weight of the liquid displaced by A is equal to weight of the part of A immersed in liquid. No, it's wrong, right? Weight of liquid displaced by A. Now, what is the equation for upthrust? Weight of water displaced by wood, or weight of liquid. Here, in this case, weight of liquid displaced by A. No, weight of liquid displaced by A. The weight of liquid displaced by A is equal to weight of the part of A immersed in the liquid. What they have said? Weight of liquid displaced by A is equal to upthrust. No, now they have said that upthrust is equal to weight of the portion immersed in water. No, it's wrong. No. The upthrust is equal to total weight of A, not the weight of the portion immersed in water. It's wrong. Weight of part of A immersed in liquid. No, it's wrong. That is equal to total weight. Third one, the volume of the liquid displaced by A is equal to total volume of A. No, it's wrong. I said you the volume displaced by this is equal to, now is what is no. Now let me take this as a V. If this the part of the object immersed in water as V, therefore displaced volume is also V. Displaced volume of, let me take this as A. In this A, the part of A immersed in water as V. No, part of A immersed in water as V. Okay, that V is the displaced volume of this A. That V is the displaced volume of A. Now, what is I said? Volume of liquid displaced by A is equal to total volume of A. No, it's wrong. The volume displaced by A is equal to volume inside the water. This is the volume, not the total volume. It's wrong. Fourth one, density of A is equal to density of the liquid. No. How can I say density is equal to density? Now, let me take this object here. It is fully immersed in water. It is fully immersed, and it stays at this position. This A is fully immersed and it remains at rest in the middle. Inside the water, it is remaining at rest. Then only I can say, now let me take density of liquid as dl and density of A as dA. Then only I can say density of A is equal to density of B. Now I can't say, now this is partially immersed. No? Then I can't say density of the object is equal to density of liquid. When can I say density of A is equal to density of liquid? Only when the object A is inside the water. And when it is at rest. At that instance only, I can say density of liquid equal to density of object.